So today we are looking at 5-4 inequalities in one triangle. And this is a tool that you'll see on the module for today that I wanted to look at with you first, so you can kind of visually see what we're going to be talking about. And then you can also go on and play with this yourself so you can get an idea of exactly what we're talking about. So we're talking about the side and angle relationships in a triangle. So there is a special situation that happens between the angles and between the side lengths. So the idea is for you to kind of discover this yourself as you start playing around with these angles and changing them and things like that. So what this is saying is over here is move the vertices of the triangle to explore the relationship between the largest angle and the longest side. So we're going to be paying attention to the largest angle and the longest side. So if you notice this triangle that I have here, you have the largest angle is 82 degrees, and then right across from it, you have the longest side, which is 9.1. So we want to know, is this a coincidence? Is that just one particular case, or is that true for everything? So if we kind of just play around with our angles, let's look. So now this is the largest angle, it's 87 degrees. I look across from it, and I also have the longest side. Let's try another one. So if I kind of make this, drag this around, this is the biggest angle, this is still the longest side. Kind of got that off the screen there. Okay, this is the biggest angle, this is the longest side. There we go. So here's the largest angle, here's the longest side, and if you notice it kind of, however I change these in any way, what happens is the largest angle is always across from the longest side. So largest angle, it's going to be right across from the longest side. And that's what it says here in kind of just a bunch of words. So in any type of triangle, in a right triangle, obtuse triangle, or in an acute triangle, you have this relationship. So when you look at a question like this, which angle measure appears to be the smallest in triangle MNP? So if you look at this, N looks like the smallest angle, right? It's very small. And if you look at the side lengths, it's also across from the smallest side. So we can kind of come up with this idea that the largest angle is across from the largest side and the smallest angle is across from the shortest side. So let's look at applying that to this lesson in the chapter and take a look at our notes. All right, so what we just kind of talked a little bit was a triangle, angles, and the relationship that it has with its sides. So we're going to talk some more about triangle sides and the relationship that they have. So this is topic 5-4. This is inequalities in one triangle. This is going to be our second to last lesson in chapter 5. So we'll have one more after this, then we'll do some review, and then we'll have our chapter 5 test. So let's talk about the triangle inequality theorem and what that is. So this theorem says that a triangle exists if the sum of the two shorter sides is larger than the third side. Is larger than the third side. Meaning, if we take the two shorter sides, okay, and we add them together, should be larger than the third side. And if that's the case, then we can create a triangle. Otherwise, we can't create the triangle. So basically, that is now a fact for you to know, and then you can determine if any three given side lengths could form a triangle, and then we'll prove our answer with an inequality. So that's what we're going to be doing with these problems right here. So I will test out a couple. It's super easy to check, just some simple addition, and then you can check some too. So basically, we take the two smaller sides, or the two smaller numbers, we add them together and we see if they're bigger than that third largest side. So for example, on number 1, I have 8 and 17, right? Those are the two shorter sides. So I'll add them together and I will see if they're greater than 24. So 8 plus 17 is 25. Is 25 greater than 24? Yes, it is. So this could be a triangle. Okay, so I am going to kind of just put a little note here to the side so that, if you're looking back at these notes and you're wondering, wait, what just happened right here? This is what we did. So we add the two smaller numbers, which represent the sides. Add the two smaller numbers. Check if they're greater than the third number. Okay, so that's all we do for these types of problems. So it's very easy to do, but you have to know what to do. So we're taking the two smaller ones, we're checking if they're bigger than the third. So for example, on number 2, let's check 3 plus 3. Does that give me something that's greater than 7? So is 6 greater than 7? That looks like 2 7s, but that's a greater than sign. So is 6 greater than 7? No. So that could not be a triangle. Very simple. Let's check another one. 25 plus 35. Is that going to give me something that's greater? Oh, I just did that out of order. I meant 25 plus 12. I do have that out. So just 25 plus 12, because those are the two shorter sides. Is that give me something that's greater than 35? So 37 greater than 35. Yes, it is. So yes. So those would form a triangle. We'll check one more, number 4, and then I'll have you actually go ahead and just check the other 4 so you get practice on your own. So you have these 3 side lengths, and then you have the 2 smaller ones are 37 and 42. So would they give you something that's greater than 52? Yes, they would. So 79 is greater than 52, so that's a yes. So you go ahead and just do the math with these next 4, just so you get some quick practice with it, and then I will tell you the answers. So pause and try those out. Okay, so hopefully you tried those. And here's the answers. So we got a no, yes, no, and yes. So if you got any of those wrong, might have been some addition errors, adding the wrong 2 numbers or something like that. And that's it. Okay, so now let's kick it up a notch. So now we're going to find a third. We're going to find a third side range, meaning a range of values that third side could be. Okay, and x would be the third side. So if it's given 2 sides of a triangle, you can set up an inequality using the sum and difference to show the range of possible lengths for the third side. Okay. So basically, we subtract these two numbers and we add the two numbers, and then that gives us a range for what that third side could possibly be. So, for example, on number 9 here, I'm going to subtract first 22 minus 14. So 22 minus 14 gives me 8. Okay, so that's the difference, and then I'm going to add them. 14 plus 22 gives me 36. So that is the range of numbers that the third side could be. So the third side could be anywhere from 8 to 36, or in between 8 and 36. So how we write that as an inequality is let's say x, okay, needs to be in between 8 and 36. So that's the range of values that the third side could be. Basically, so let's test out some numbers just to show you kind of. 9 falls in that range. Okay, so if I had 9, 14, and 22, okay, that means the two shorter sides are 9 and 14. 9 plus 14 would give me 23, which is greater than 22. If I had anything less than 9, such as 8, then I'm not going to get something that's bigger than 22. Okay? So any number now that's greater than 9 but less than 36 would fit that criteria. So for example, let's test out 37. 37 is bigger than this, so it doesn't fall in the range. So if I had the number 37, okay, then I'd have 14, 22, and 37. So if I add 14 and 22, I get 36, which is not bigger than 37. Okay, so it needs to be something that's less than those two numbers. So that gives me the range right there. So that's what I'm going to do for every problem to find the range. Let me put over here on the side. So when you write this inequality, okay, so I'm going to say A for any number A, and X represents the third side, and then any number B. A is the difference of the two numbers, and B is the sum. And if you do that every time, that's how you get your ranges. So for example, I'm going to set this up. I can honestly, you can just write it every time like this. It might help to do that so you don't mess up your sign. So you're always having X in the middle and then these two signs. And then I'm going to subtract 31 minus 28. So I'm going to take the difference of the two numbers, which in this case is 3. So 3 goes over here. And then I'm going to add 31 plus 28, which gives me 59. So now my range is anything between 3 and 59. And then notice the one thing is that an inequality symbol, so it's not less than or equal to, so it can't be 3 or 59. So it's non-inclusive. It does not include 3 or 59. If we plugged in, or if we used 3 for the third side, and then we added the two shorter sides, you're not going to get it. It's not going to be greater than that number. It's going to be equal to, and it has to be greater than. For example, 28 plus 3 is 31, and we need it to be larger than 31, not equal to 31. So how about I do one more, and then you guys will try the last 3. So I'll do 3, and then you try out 3, and then we can put our answer. So just, this is, there's not a lot of calculations to this problem. You just have to know what to do. So you have to practice it in order to get what you're doing. So first thing I'm going to do is find the difference of 11 and 3, which gives me 8. And then I'm going to add 11 plus 3, which gives me 14. So I'm going to write my x in the middle. So x has to be in between 8 and 14. And now I'm going to have you try the next 3 and see how you do with them. So go ahead and pause and try these next 3 problems. Okay, so there are the answers for the next 3. So hopefully you gave those a try and you can see what you should have gotten. And now let's take a look at a couple questions that would be more test style questions, so something you could see on an EOC or a midterm or something like that. So 15 says, if a triangle has lengths of 15 feet and 27 feet, check all the possible lengths for the third side. So we want to now know our range for that third side. So we're going to do the same thing as before, and now we just have we might have more numbers that fit into that range. So the first thing I'm going to do is 27 minus 15, which is 12. And then I'm going to add them, 27 plus 15, which is 42. So now I know very easily what my range is. Now, of course, there's another way you could answer this problem. Let's say you kind of forget how to do this, it's a test. You can also just, guess and check. Okay, take 44, add 15 and 27. Does that give you something that's larger than 34? Take 12, add 15 and 12. Does that give you something that's larger than 27? Okay, so you can do it that way, or you can do the range. So I need any number that falls in between 12 and 42. So 34, is that in between 12 and 42? Yes, it is. So I also know if I add 15 and 27, that gives me something that is greater than 34. It gives me 42. Now 12 cannot be included. So 12 would not work. If I add 12 and 15, that gives me 27, which is not greater than 27. Let's try 29. 29 is in between 12 and 42. And if I were to add 27 and 15, I would get something larger than 29. 18 also falls in that range. 43 falls out just outside of that range. So those would be my 3 choices. Okay, so go ahead and try number 16 on your own so you can get some practice with this, and then we'll take a look at the answers. So go ahead and pause and try. And there's what you should have gotten for 16. All right, let's go ahead and take a look at the back of this page. All right, so we're going to order angles. And this goes more along with that original example that I showed you on Canvas, the module where I can play around with the angles. So the angles of a triangle can be put in order by comparing the sides. This is what I said before. The smallest angle is always opposite the shortest side. And then the largest angle is always opposite the longest side. So you can always order the angles from least to greatest by just looking at the lengths of the sides. So my smallest side will be across from my smallest angle. So least to greatest. Here's my smallest side, right? 7. So the one opposite from that is A. So that means angle A is the smallest angle. Next one that we have is 10 feet. So right in the middle, that is across from C. So we would have angle C. And then our largest angle is across from that 13, which is the biggest side. So it'll be angle B. All right. Now we're going to order sides. So now kind of going backwards, same thing. The sides of a triangle can be put in order by comparing the angles. The shortest side is always opposite the smallest angle. And then the longest side is always opposite the largest angle. So let's order the sides from least to greatest over here. So the smallest angle is going to be this angle here, angle F. Even though they don't tell us what that is, we could subtract those angles from 180 and get the value of that. And you can also see that it's smaller than the others. So if we draw a line from that angle, that's the smallest one, to this side. So you're looking at DE. That's the smallest one. Next smallest angle is 42. So if we draw a line to its opposite side, we're at DF. And then the largest angle, 103, draw a line to its opposite side. That is EF. Okay. So now we're just going to go through and order some angles from least to greatest, and then also greatest to least. So set 1, order the angles from least to greatest. So here we have the sides, and we're going to list the angle. So smallest side is 17 meters. So angle M would be our smallest angle. Then we've got 20, which is across from angle P. And then we have 24, the largest, which is across from angle N. And that's it. So that's least to greatest. So go ahead and try to order number 2 on your own. Pause and just try number 2 real quick. And then that's the order you should have gotten. So angle T, across from 30, the smallest, then 35, across from angle R, and then 38 across from angle S. Okay, now let's order greatest to least. So going opposite direction. So just super important to always really read the directions, because that's an easy way to get a test question wrong by not realizing that it says greatest to least. So greatest over here, we have the largest is 11. So we're going to have angle C, then angle B, and then angle D. So that's greatest to least. Go ahead and try number 4 on your own. Pause the video and give that one a quick try. All right, so if you tried it, you should have gotten X, Y, and then W. So 43 is the largest, that's across from X. second largest is 29, that's across from Y, and then the smallest is 26, which is across from W. Now let's take a look at 5 here. So I've got 3157, and I actually just am going to go ahead and figure out what the third side is, so that I know exactly what angle K is. I'm just going to write here what I'm doing, but I'm going to do 180 minus 31 minus 57, and that is going to give me 92 degrees. And then that'll just help me ordering the side. So the least to greatest, the smallest angle is 31. So it's going to be across from KL. And then the second smallest would be 57, which is across from JK. And the largest, 92, is across from JL. And that's it. So go ahead and try 6. Find that angle first by subtracting from 180. Okay, so you should have gotten this order here, ST, SB, and TV. And this angle here was 59 degrees. All right, now let's order them from greatest to least, so opposite direction. So first, I'm going to figure out, I'm going to subtract these from 180. So 180 minus 82 minus 54 gives me 44 degrees. So greatest to least. So my largest one is 82 degrees. So that's going to be XZ first. Second largest is 54 degrees. So it's going to give me YZ. And then my smallest is Z. So that's going to give me XY. Okay, and last one, why don't you go ahead and try number 8 on your own and then check back in. Okay, so if you tried that, here's what you should have gotten. So you have, this was greatest least, so the largest one was the 90-degree angle, so BE, then we had BD, and then DE. And that is it.